Hello Python friends on YouTube. Welcome to another playlist and series. And this series we are going to talk about Python and databases. And we're going to start off with the SQLite and create a database there. So a little bit about this new series is that as a database as an abstraction on top of an operating system's file system to ease creating, reading, updating, and deleting persistent data. So why are databases necessary? At a high level, a web application store data and present it to users in a useful way. So databases make structured storage reliable and fast. They also give you a mental framework for how the data should be saved and retrieved instead of having to figure out what to do with the data every time you build a new application. So I wanted to also learn and practice more databases. So databases is something that I have tried to understand and also try to practice a lot over the time. And in this series, we are going to talk about the different implementations. We might be getting into Postgres, SQL, MySQL, and we'll start off with the SQLite. Also try to get into the non-relational databases, which are also called NoSQL. So like DB Mongo, MongoDB, CouchDB, different type of NoSQL databases also we're going to talk about. So let's start off with SQLite. So SQLite, before I get into this table, so SQLite 3 is the one database that we are going to work with, and it's embedded relational database. So in this series on SQLite 3, we are going to implement an embedded relational database with SQL support. And the SQLite 3 module implements the Python DB API 2.0 compliant interface to SQLite, an in-process relational database. SQLite is designed to be embedded in applications instead of using a separate database server program such as MySQL, PostgreSQL, or Oracle. It is fast and rigorously tested and flexible, making it suitable for prototyping and production deployment for some applications. So this series is going to be a very practical approach to working with databases. So first of all, we're going to create a database. An SQLite database is stored as a single file on the file system. The library manages access to the file, including locking it to prevent corruption when multiple writers use it. The database is created the first time the file is accessed, but the application is responsible for managing the table definitions or schema within the database. So what we are going to create is a file that looks for database file before opening it with connect, with the connect function, so it knows when to create the schema for new databases. So let's start pushing those keywords. Let's import SQLite and OS. And define our file name. Case DBs, yeah, not in case, but if the database is new. Just checks for the path with the file name. And we define our connection. File name, just print out a simple message to tell them that we need to create a schema if the database is new, and if it's already existing, we'll print out some other message. So, and then we close the connection. And let's save this file in a place that I can find it again. SQLite. Yeah, we can save it. I will just override it because I tested the let's change our working directory is there, and now let's see. Let me just clear this. And let's try to run it. Or before we do that, second, let's create it up. And before I run it, we'll just see that there is no database file yet. So if we run it once, it tells us it's need to create the schema. And if we check the file, now it has a file. And if we run it again, the database exists, but we need to create the schema. So when we are running the script twice to show that it creates the empty file if it does not exist. So after creating the new file, the next step is to create the schema to define the tables within the database. The remaining examples in the tutorials are all use the same database scheme for this SQLite tutorial with tables for managing tasks. The details of the database schema are presented in this table. So we are just going to create a database for a to-do application. And these are the columns that we need. We need for the project table, we need the name, it's of type text, and the description of the project name. And next is the description column with the text type. And it's going to be a long project description. And then we need a deadline for that project of type date, which is a due date for the entire project. And the tasks are need to have an ID with the type text, which is a unique task identifier, and a priority column with the integer type, numerical priority. Lower is the more important integer. And then we need the details column with type of text, which is a full task details description. Then we need the status column of type text, and we can, for example, task status is one for new, pending, done, or cancelled. And we need another column which is for deadline, which is a date type, and this is for setting a due date for this task. And then we have a completed on column with the type date, which tells us when the task was completed. And then we need a project column, which is of type text, and the name of the project that we want to connect this task to. So that's what we are going to create. So let's go over to our editor, and when we are creating SQL comments, they start with 2 dashes. That is the comment type with the SQLite 3. So let's create the tables with the data definition language, DDL statements. So this is a schema for to do application examples and projects. These are just comments. Activities, tasks. So create table project. Name is the column, and then the text, and it is primary key. And the description. Let's just space this out a little bit more. Description is text, and deadline is a date. Close. And then we need to go in the task tables table. Project. Again, these are just comments. Create the table. Need the ID, which is integer. Also the primary key. And it auto increments and not null. And priority is an integer with default starting at 1. Highest priority. And the details is text, and status is also text. And deadline is date. And completed on is also a date. And then we have the project, which is text and not null, and references to project name. Close it with a semicolon. Save this file as your working directory with name to do schema.sql, not .py, because this is a schema file. And now let's create a file that creates the schema file. And we start off by importing OS and import SQLite 3, and define our file name. then our schema file name, which is to schema.sql. I'm sure that we have the database. We open our connection to our database. If the database is new, then we just print us a message. Open our schema file in the right mode, SF, read the schema file and execute the script. Schema, and we execute with the red file, and now we can start putting out some messages to the user. I'm going to pause the video just to save time, because there are just many statements that we are going to use to execute our to create our tasks in our database. So I'm going to pause it, and you can I'll restart it when I have put all the execution commands for the tasks in the file. So this is where we left off. So these are, we create our first project with a name, description, deadline, and the values are sing, YouTube channel, and the deadline date. And then we insert 3 tasks into that project. We insert to record a video, done, and the deadline and which project it's connected with. And the next line is just to publish a video, and its status of waiting with the deadline in the project name. And the third task is to get more subscribers, which is an active task, and deadline of 15th of July, and the project name. So let's try to run this command, and first just save this. And we'll save it as SQLite 3 create schema.py, and let's just remove this todo.db. And it's removed. The database does not exist. So now let's try to create our database, and it says it's creating some schema and inserting some initial data. So if we go back and start our SQLite, let's see, no tables, and we open our to-do database. Let's change for tables, and has project table and tasks, and let's select all from task table, and we get our tasks that we did. So like I said, these videos are going to be more a little bit practical, not so much information that will be in other video tutorial series. So this is just to practice the SQL and working with databases and Python. So I hope you enjoyed this the new type of video, which is less talk and more do. So I hope you like it. If you enjoyed the video, please do subscribe, like the video, comment, share, anything. And hope to see you in the next video where we are going to start to retrieve data through Python. So thanks guys, and see you in the next video. Bye.